Hi everyone, Lloyd Rieber here again with our next example of using Excel to compute some statistics. In this video, we'll begin using Excel in earnest as a tool to compute descriptive statistics. This video tutorial is divided into two parts. Here, in part 1, we'll compute the mean and standard deviation of a set of data. Then, in part 2, we'll continue to compute z-scores for all of the raw scores. A reminder that I will talk rather quickly, so be sure to use the pause and rewind controls as needed. A reminder also that I'm using the Macintosh Excel 2011 version, so if you are not, then you'll need to translate my actions for the particular version you are using. Okay, let's get started. The first step is we need to launch Excel, so if you haven't, pause the recording and do so. Next, let's immediately choose to save the spreadsheet. We'll choose Save As from the File menu and give the spreadsheet a descriptive file title. You'll notice that I created a folder titled Descriptive Statistics, and I put that in the folder for the course. So I'm going to put this file in there. We will again use the suggested construction of all our Excel file titles, where we'll begin the title with our last name, then a hyphen, then a descriptive word. In my case, it will be Rieber-descriptive1. And save. Given the interest in online education, we'll imagine that we have just given a general attitude survey to a group of 10 new graduate students on their attitudes toward online education. The scale of the survey ranges from 0 to 40, with a total of 0 being an absolute dislike of online education and 40 being the most positive attitude one can have of learning online. Let's start by planning the layout of the spreadsheet, and a good way to do that is by entering some labels. For some reason, I always like to leave the top portion of my spreadsheets blank for different labels and things that I might add later. So I'm going to come down to row 10 and begin to put in a label. So we have, again, 10 graduate students. I'll just type in a label student, give a sense of maybe the student's name or some other identifier. Then the next column, I'm going to type in scores. I'm just hitting the tab key to move over. Now I would like to put in a label for a deviation score, and maybe we remember that a lowercase x is a symbol for a deviation score. In the next column, we are going to be squaring those deviation scores, so we will just type x squared because we have some limits in what titles or labels we can put into an Excel cell. So that's good. Now, it might not hurt us also to remind ourselves that that lowercase x represents a deviation score, so there's no harm in actually typing deviation score above. And you can see how that goes a little bit wider than the column, and there's no reason why I can't just make that column a little wider. Okay, that's a very good start. Next, let's enter some identifiers for the students. If we knew their names, we could type in their names, but let's just go ahead and enter letters A, B, C, D, E, F, G, H, I, J. And I'm just entering the character of the letter and then pressing return. Next, we will enter the scores that each of the students had on the survey, and of course we will enter that in the column marked scores. So just click on the cell at the intersection of student A and column scores, and student A's score on the survey was a 34. Student B, 22. Student C, 23. And now 29, 24, 30, 35, 37, 16, 29. And again, I'm just pressing return after I enter each of those values. And I do advise you now to stop and look and make sure that your data matches my data exactly. You wouldn't want a little careless error at this point frustrate you later, because obviously your final results won't be the same if your scores aren't exactly the same as mine. Now let's go ahead and compute the mean for this set of scores, and I will go ahead and do that right below the set of scores. Maybe put it one space there, and I like to put a label, so we'll type in mean, press return. Now we're going to enter the function for the average. And yeah, let's go ahead and use the function that Excel has for the average. So we can do it in a variety of ways. Since I know that the function actually, the title of the function actually is average, I'm going to just go ahead and type it in. So any formula or function always begins with an equal sign. Just type average. You can see again how Excel is trying to help you out by finishing the typing. I have an open parenthesis, and now what we're going to do is tell Excel the range of scores to use to compute the average. And of course we start up there with student A's score, click, hold, and drag down to student J's score, and then enter the close parenthesis and press return. Next, let's enter another very useful and simple descriptive statistic, namely how many scores there are, or I could say how many participants there were. And I know that we can see that there are 10, but this is a very useful thing to have Excel compute for us, because again we may be adding data or subtracting data later on. So yeah, let's go down below the student identifiers, and again right in line with the row where we typed in mean, let's type n, because n is the symbol for number of cases in the sample. Press return. Now there's a very handy Excel function that will count up how many cells have data in them, and the function is actually count A, and there's several counting functions. So let's use this. Now let's go ahead and explore how to insert a function the long way in Excel. Let's say you didn't know what the function was and you had to do a search for it. So if we go up to insert and come down to function, and again you could start to scroll down and look for different functions, and in fact you'll see there are different categories, and there's a category for statistics, and as I keep coming down you'll see there's a bunch there for count. The one we want is count A. If you just click once on it, you see a nice little description. It says it counts the number of cells in a range that are not empty, and I think that'll work just fine for us. And like it says, we're going to begin by double clicking on the function in the list. So just double click on count A. And this pretty much works the way we just did it. Excel wants to know the range, so once again we come over here to the starting point, and it turns out we're going to use the participant identifiers. So we're going to click and hold on A and come on down to J. And you can see that Excel inserted that range inside the function like so. And again, we can press return, and there we have a 10. Voila. So let's go ahead and close the formula builder window. Might be a good time to go up to File and choose to do a save. Now let me demonstrate something. I don't want you to do this because we want to have the 10 data points in our data set. But if I were to go to just in midway, let's say to the 16, and if I choose to delete that row, you'll notice how of course the mean changes, but also notice how the total number of participants changes to 9. Let me undo that. Very good. Okay, let's now begin to compute the standard deviation. It might be helpful to remind ourselves of the formula. So I have built a little Word file here with the formula in it. I also put, as you can see on top, the formula for the mean. I know we're very comfortable with that, but I again really want you to be familiar and comfortable with symbolism in statistics. So here we have the first one of the mean. X bar represents the mean of a sample, and that is equal to the sum of all the raw scores divided by n, and that's what the average function in Excel did for us. Now let's look down here for the standard deviation. So the standard deviation of a sample, S, is going to be equal to, well, there's a lot here. There's the square root of a numerator and a denominator, and you can see that the denominator is simply the number of participants, so that count A function that we did just a few seconds ago will come in quite handy right there. But what we need to do is start to compute these deviation scores, a person's score on the survey minus the average of the entire survey. All right, so let's go back to our Excel spreadsheet and begin to figure out how we're going to do this. Well, let's go to the first cell where we need to compute a deviation score. So student A in the column marked deviation score. So every formula and function starts with an equal sign. So that's a good place to start. Hit the equal sign. Again, remember that the formula, bring it back up, is the score that the student had minus the overall average. So we have the student's score. So I'll just click on student A's score, 34. Now notice it puts in B11 because that is the location of the score. Let's continue. We're going to subtract from that, so a minus sign. Then we're going to come down and click on the mean of that sample. And it puts in B23. Now if I press return, you'll see that it does the computation. 34 minus 27.9 equals 6.1, a positive number, which tells me that student A's survey was above the mean. Now click again on that 6.1 and you'll see we have the formula up here. So we have a great formula that we can use and copy and paste. Now there's one little problem, and that is, if you think about it, we need to have B11 changed to B12 for student B, and we need to continue that so that it will change from 12 to 13 to 14 and so on. B23, on the other hand, is always going to be this number. So if you're not too familiar with Excel, as we do a fill down or fill right, it assumes you want it to be relative, not absolute, as it references a cell, which is fine for the first part of the formula. B11, we do want it to be relative to the new position, but not so for B23. We always want it to point to B23. So to make that an absolute reference, we put dollar signs in front of the two identifiers of the cell. A dollar sign in front of the B and a dollar sign in front of the 23. And press return. So what we're going to do now is use the fill down technique. So if I click and hold on the 6.1 and drag down all the way to the row for student J, and then I go up to edit, choose fill, and choose fill down. So take a moment and look at your numbers and see if they match mine. And if you just click on any one of these in the middle, you'll see again that the first part of the formula will be relative to that particular student. So I am in B14, but the B23 should never change. And by the way, it is very easy to get a little confused in Excel if you start clicking in different places where you are inadvertently telling Excel to add to the formula. So for example, if I were just looking around here but sort of inadvertently came up here and clicked and then clicked here, look what's happening. It said, oh, you must want to add C14. No, I don't want to do that. Be mindful of the fact you can always exit out of making a change to any particular cell by hitting the cancel, which is this little X in a red circle. So just be very careful of that. There's so many times that will happen, but again, it's very easy to get out just by hitting the X in the red circle. Okay, well, what's next? Well, let's go back to our formula, and we see what we need to do is take that value, that deviation score, and we need to square it. All right, let's do that. Let's go back to our Excel spreadsheet. We'll go over here to the cell, again for student A. And there are a couple of ways of squaring a number. We'll do it in a very simple way. Let's start again. Let's make sure we are in the correct cell. I'm in D11, right beside the deviation score for student A. And it's a formula, so I'm going to start with an equal sign. I want to square a number by simply multiplying by itself, so I click on the value. I then enter an asterisk, which stands for multiplication, and then click on the number again. Press return, and there we have the square of 6.1, 37.21. So now we can very easily use the fill down technique to do the same for each of the other students. So we click and hold on the first one, drag down to the last one, student J, go up to edit, and choose fill down. And of course, in this case, every single one of these formula will be relative to the new position. Okay, we're making good progress now. What's next? Let's look at the formula. What we need to do now is sum all those up. So we have the sum of all of the squared deviation scores. Easy to do in Excel. Let's just go down and we'll again add some labels. Let's go ahead and add the label sum right there. It's nice. It's in the line with, or the row with n and mean. Press return. And I think you remember how to do a sum of a series of numbers. The function is simply sum, so we can just type that. Start again with an equal sign, sum, open parenthesis, then we're going to take the first deviation squared, click, hold, and drag to the last deviation squared. And don't forget to close that parenthesis. Perfect. This is actually a good spot to do a little check of our arithmetic, because the sum of the deviation scores themselves, if you recall, should be 0, because you have this mathematical balancing that the amount above the mean exactly equals the amount below the mean. And since we've already done a sum, we can use the fill left technique to actually check that out. So if you just click and hold on sum, the value of sum, and go to the left, and go up now to edit and choose to fill left, you will see we have, well, not 0, but it actually is very close to 0. This is actually scientific notation. And I'm glad this came up so that you see it. We're going to be doing some rounding very soon. But what this actually stands for is 1.42109 times 10 to the negative 14. So when you multiply with an exponent of 10, you're actually moving that decimal point either left or right. If it's a negative 14 like we have here, we'd be moving the decimal point to the left 14 places. So if you can imagine 0.000000, and I'll lose count, but eventually we come over at the 14th place to a 1. So it's practically 0. Why isn't it exactly 0? It's because of a rounding error. And we might as well go ahead and round that off now. We might as well round off all the numbers in that particular row. So if you come out here to the row number, row 23 in my case, and click to highlight the row, you can come up to Format, come down to Cells, and you can format the cells. A lot of things you can do, but we will go to the category number, and decimal places, let's just leave it at 2. Click OK, and now you see 0.00. So this is a good, again, check of our mathematics. If the sum of the deviation scores, which are in my column C, were anything except 0, that would be a clue that I did something incorrectly. Okay, well, what now? I suggest we go back and look at our formula. So it looks to me like we have all the pieces we need. We have the sum of the deviation scores squared, so we have our numerator here. We have n, and we're going to have to figure out how to take the square root of that fraction. But I think we can handle that in one in one formula. Okay, good. Let's go ahead back to Excel, and let's go ahead and enter a label. And again, I suggest we enter it right about here, right below the sum of the squared deviations. And I'm going to type standard deviation. And I'll go ahead and make that column wide enough for the label to fit. Okay, so we are going to do this by hand, and I will tell you that there is a standard deviation formula in Excel, but we will deliberately not use that now. We want to do it by hand in order to really understand this, and then we'll come back and use the Excel function for standard deviation to check our work. Okay, let's check that formula one more time. So it looks like what we need to do is again take the square root of something, right? And that something's going to be the sum of the squared deviations divided by the total number of students. Okay, so square root of those two things. We start, as always, by entering an equal sign for a formula. And I happen to know that the name of the square root function is sqrt. So just enter that, and then an open parenthesis, knowing, of course, we will have to eventually close that parenthesis. So the numerator is the sum of the deviation scores squared, so click on that value. We divide. We need to divide, so hit a / the divide symbol, and we're dividing by the total number of participants. Click on that value. And now close our parenthesis. Now press return. And we see that the standard deviation is 6.26817 and so on. This is another good opportunity to do some rounding. Let's round all the values in this particular column. So I'm going to click on the column name, D in my case, then go up to Format, Cells, go to Number, and again I think 2 decimal places would be fine. Click OK. And there we have a standard deviation of 6.27. Now let's check our work. In the cell right below the standard deviation that we just computed, we're going to insert the function for a standard deviation from Excel. Now this is a good place to remind ourselves of the difference between samples and populations. So if I go back to my formula, I see that this is the standard deviation formula, S for standard deviation, but of a sample where I am not interested in inferring anything of the population. So in this case, I have n and not n minus 1. If I was interested in inferring from this sample to the population of graduate students, I would have to divide by n minus 1. But since I am not making inferences to the population, the standard deviation formula we have to use is the one for the population. I know it's as clear as mud, but trust me. So let's go ahead now back to Excel, and we have to keep that in mind, okay? So if I click on the cell, and let's go ahead and search for the formula. Let's go up to Insert, come down to Function, and let's come on down, scroll down till we come to the statistical functions, and we will see when I get to the yes, for standard deviation. There are several. The two that we need to be distinguishing is this one, stdev.p, and you can see that it is going to be computing or calculating a standard deviation based on the entire population. Compare that to stdev.s. It talks about out of a sample. So again, ours is, we called it a sample, but we are not interested in inferring anything to the population, so we are going to use the formula for a population, which is the .p. We're going to double click, and in order to use this function, we are using the student's scores, and it's going to do all the rest of the calculation for us. So I'm going to click, hold, and drag down from the 34 down to the 29, and then press return. And Again, notice that we have exactly the same standard deviation. So that's a good check of our work. Now, if you were to try this out and try the other standard deviation formula for a sample, it will be slightly off. You could go back into the one we did by hand, and what we would have to do is subtract 1 from A23. Okay, excellent. We have done it. We have computed by hand a standard deviation. In the next video, we're going to continue working on this Excel spreadsheet file, and what we're going to do is add z-scores. We're going to calculate z-scores for each of the students' raw scores. So before we end this video, let's be sure to go up to File and choose Save. Until next time.